Hello friends, welcome you all to my channel Civil Engineers. Today we are going to understand the basic concept of double integration method, and let us begin by cantilever beam. And here is the question: a cantilever beam subjected to single concentrated load. How will approach to this question? Let us first make the pictorial form of this question, and it has told that cantilever beam it is subjected to concentrated load. See, it will be like this. It is a cantilever beam and it is subjected to a concentrated load. Now let us suppose its length is L. Now what we have to do is, since it is given that the beam is cantilever, so no need of finding reaction. Directly we'll find the mxx here. For that we have to understand how we have to cut the section, and it is very easy friends. Let's see, you will understand. We will cut the section in such a manner that it includes the load. Let us suppose we are taking this part as x, then it will be L minus of x. It will be L minus x. Now we have to form the equation of mxx, our first step. Mxx, that will be equals to C. Here we have to apply sign convention, and sign convention says it is, let us suppose it is a section, and if any force if it is acting upward direction to the left of the section or to the right of the section, we have to take it as a positive. And one more, let us suppose this is a section and any force that is acting downward, then we have to take it as a negative. So by using the sign convention we can form the equation mxx. Since C, this load is acting to the right of the section and it is going downward, so we have to take it as negative minus w, and its distance is L minus of x. And we know that one equation is there, the E into I d square y by dx square, and that is equals to minus of mx. Here you might get confused with minus term, but no need of getting confused because we know that in many books it has been given that E into I d square y by dx square, that is equals to plus minus of mxx. So you can take it as a positive also, you can take it as a negative. In this video I am taking it negative. Now let us proceed. I will write the equation in the, I will write whatever I formed the equation mxx in this equation. See, E into I d square y by dx square, that is equals to w into L minus of x. Here minus minus get cancel. If you here if you want to open this, it will be good if you open it, otherwise there is chances of getting error. So better open this like this, and let's say it is an equation 1. Now integrate it for the first time. We will get E into I dy by dx, that is equals to w into L into x minus w into x square by 2 plus c1. Now we have to integrate equation 1 for the second time, and we'll get like this: E into I into y, that is equals to w into L into x square divided by 2 minus w into x to the power of 3 divided by 3 into 2. plus c1 into x plus c2. This is, let's say this is equation number 3. Now what we have to do is we got equation number 1, equation number 2. Now our main focus or main aim is to find the values of c1 and c2. For that we have to determine the boundary condition, and here and for that I am taking the reference figure to determine the boundary condition. Let us suppose we are taking this as a origin, then it will be 0 0, and it is total length of the beam is L. So here x is equals to L and y will be maximum, and dy by dx will also be maximum at this particular point. Here x will be 0, y will be 0, and dy by dx will also be 0. See here, since the load is acting at this point, so the beam has tendency to bend in this manner. So so we can see that here deflection is also maximum deflection, and slope, whatever slope we'll get here will be maximum. This is our boundary condition. Now let us write so that further we'll not get confused. Our first boundary condition is x is equals to 0, y will be equals to 0, and dy by dx is equals to 0. And second boundary condition is x is equals to L, y is maximum, at x is equals to L, y is maximum, and dy by dx is also maximum. Now let us find the value of c1 and c2 by using equation 2. So equation 2 says dE into I dy by dx, that is equals to w into L into x minus w into x square divided by 2 plus c1. This is the equation number 1. Equation number 2. Here we will put x is equals to 0 and y is equals to 0 and dy by dx is equals to 0. So these terms get 0, and we are putting x is equals to 0, so this term gets 0, and this term also gets 0. So we are getting c1 is equals to 0. Again equation number 3. By using equation number 3 we get WLX square by 2 minus w into x to the power of 3 divided by 6 plus c1x plus c2. Here also we'll put x is equals to 0, y is equals to 0, and dy by dx is equals to 0. Since y is 0, so it will be 0, x is 0, x is again 0, and c1 and x is 0, so this is 0, and c2 also we are getting 0. So equation 2 becomes E into I dy by dx, that is equals to w into L into x minus w into x square divided by 2, and c1 is 0, no need to write this. This equation is also known as slope equation, right? And equation 3 becomes E into I into y, that is equals to w into L into x square divided by 2 minus w into x to the power of 3 divided by, so this is 6 divided by 6, and no need of writing c1 and c2 as it is 0, and this equation is known as deflection equation. Now our aim is to find maximum deflection and maximum slope, right? So by using slope equation we can get maximum slope, and by using deflection equation we can get maximum deflection. So I am using slope equation first. E into I into dy by dx, that will be equals to w into L into x minus w into x square divided by 2. And here if I put x is equals to L, I will get maximum slope. Why? See, at x is equals to L, only I am getting maximum slope. Okay, so I am putting x is equals to L. So here dy by dx, and it will be maximum, that is equals to w into L minus w L square divided by 2. Once you solve this, you will arrive at one particular form, that is w L square divided by 2 time of E into I dy by dx maximum. This is our maximum slope, and now we are interested in finding maximum deflection, and for that I will use deflection equation which I have obtained here. This is the deflection equation which I have obtained. I will use this E into I into y, that will equals to w into x square divided by 2 minus w into x to the power of 3 divided by 6, and here I will put x is equals to L in order to get maximum deflection. See, here only I am getting maximum deflection also, so I will put x is equals to L, right? X is equals to L put, so I will get y maximum as w into L square divided by 2 minus w into L to the power of 3 divided by 6. Once you solve this, you will get y maximum as w into L to the power of 3 divided by 3 time of E into I. You will arrive at this point. So this is our required maximum deflection, and this is our required maximum slope. Thank you friend for watching my video. If you like the video, please subscribe the channel, and don't forget to like it and put comment if any further improvement is to be done. I will consider it, and I will improve in the coming videos. Thank you friend.